This is a video over part of the lesson for straight line motion and where we're connecting position, velocity, and acceleration. We've talked about these topics before, so this is just going to be another connection to this. And there's a whole bunch of information that we're going to have here. So like all of these equations that are on your notes, and I'm not going to take the time in this video to go through that. We'll do these things as we go through the video. We'll determine those things, and then, as we do examples, we'll further define them. So these are all the things on that front page of your notes that you need to pay attention to. And so when you're unsure about something to do, of course, you can also look on there. So basically, we're going to really connect all the things that might be on there. And then right now we're doing straight line motion. Second semester, we'll kind of expand all this to curved paths. So our particles aren't going to just move in a straight line, but the ideas will be very similar. So that's why it's really important for us to really get this down. And then our BC only topic will have the particles moving in curves or not just straight lines. Okay, so let's start with our first example, example 1. So we have this particle moving along the x-axis, and we have this function called x of t. We also notice that at any time greater than or equal to 0, so that's the time that we're starting at. So A says at time t equals 0, determine whether the particle is moving right or left. So we need to know how we tell which direction the particle is moving. So the way we determine that is by the velocity. And then remember, you have to show how you get that. So x prime of t equals v of t. Now I've just shown someone that I'm aware that the derivative of the position equation is the velocity. And then I go ahead and do my derivative. Okay, and then I need to find out what is happening at t equals 0, because velocity, positive means it's moving to the right, negative means it's moving to the left. And they told us it's moving on the x-axis, so that's how we know right or left and not up or down. So we simply plug in. So I really don't have to show this part of it, but for your notes I will. But as long as I say I'm doing v of 0, then I'm fine. I can just get the answer, which is -12, because that's pretty simple to plug into. Now I need to give an answer to the question, how do I know? Or so first of all, tell me which way it's going, and I would say the particle is moving left, because v of 0 equals -12, which is less than 0, and that's it. And that's all you have to say, because at velocity negative, it's moving left, velocity positive, moving right. So there's that one. Now, at what time or times does the particle change directions? Okay, so in order to determine if the particle is changing directions, it means it has to change signs. Well, the only place that a function can change signs, in this case a polynomial function, is if it equals 0. So if it had been something else, it could be rational, then we might have to find undefined places, but in this case, we just need to find out when does this thing equal 0. So we would simply set it equal to 0, and then we would solve it. Now remember, a lot of these questions are definitely going to be on the non-calculator portion, so we have to be able to do the work, and that's where we've talked about factoring. It needs to be just second nature. You don't even think about it. Now, remember, you're watching a video, so you can certainly slow this down or hit pause, and then you could try your factoring. So I get answers of t equals 4 and t equals -1. Well, my time, remember we underlined, is only greater than or equal to 0. So we're just going to simply put an x through that. I don't like to say anything else, just cross it off. Don't erase it. There's nothing wrong with it's part of your solving, but it's not the one that's going to be relevant here. And then what we need to determine is, does it change sign there? Okay, so what I like to do is just make a little chart, and I put time is 4, and I'm going to put 0 here because that's where it starts, and then it just goes on after that. And so I'm going to look at, what is my velocity equal? Well, at 4, it equals 0. That's what I just figured out. And then I need to pick any number between 0 and 4 and plug it in. It's either positive or negative, but they can't switch until it gets to 4. So I pick anything. So like, let's pick and just plug it in right here to figure out positive or negative. So if I pick like 1, I'm going to have 1 minus 4, which is negative, and 1 plus 1 is positive, so I'm going to get negative there. And then I pick a number between or bigger than 4, so pick like 5, and I'm going to get 5 minus 4 is positive, 5 plus 1 is positive, so I'm going to get positive there. So then we can say at t equals 4, the particle changes direction from moving left to moving right. Since, and we always have to give a reason, v of t changes from negative to positive at t equals 4. And there you go. Now, if I had units in the problem, which I don't, I would say t equals 4 seconds, and I might give, other things, but I don't have any units here, so we're good with that. Just make sure when you do have units that you answer them that way. Okay, C says at t equals 1 is the velocity of the particle increasing or decreasing. Well, if we have a function and we want to determine whether it's increasing or decreasing, we would look at its derivative. So if we look at the derivative of velocity, which we call the acceleration, we're going to find out that the derivative of velocity, or the acceleration, whichever way you want to look at it, we just take the derivative of that equation right here, right? There's your velocity. So we take the derivative, and we're going to get 6t minus 9. And then we want to find out what's happening at 1. Again, here's the reason that we don't write paragraphs and stuff. We just use math. So we say a of t is 16 minus 9. So a of 1 says, hey, I'm plugging 1 in, and I'm going to get negative 3. Well, since velocity's derivative is negative, then that means the velocity is decreasing, because that's how we tell if a function is increasing or decreasing. So we would say the particle's velocity is decreasing at t equals 1, since a of 1 equals v prime at 1 equals negative 3, and then just put less than 0. Now I like to relate it to v prime because that's why it is decreasing, is because its derivative is negative, and we know that's how increasing, decreasing works for functions. So then D says that t equals 1 is the speed of the particle increasing or decreasing. So this is a little bit different. This is saying, is it speeding up or slowing down? So to determine if it's speeding up or slowing down, we need to determine if velocity and acceleration have the same sign or different signs. Okay? So we want to find out, what is velocity doing at 1? So the velocity at 1 is going to be negative, and actually you could put a couple of steps in, 3 minus 9 minus 12, and we get negative 18. And then we know that the acceleration at 1 was negative 3. So then we will say the particles the particle is speeding up, or I should say the particles, let's say the speed is increasing. It's the same thing, but we probably should always use the words they did. So the particle's speed is increasing since acceleration, which is less than 0, and the velocity at 1 is less than 0. They have the same signs. Remember, it doesn't matter if they're positive or negative. They're both kind of working in the same direction, okay? So the particle speed is increasing. Again, try to copy what they ask you. Is it increasing or decreasing? The particle speed is increasing since acceleration is greater than 0 and velocity is greater than 0. They have the same signs. Okay, so since those things have the same signs, speeding up. What is the particle's acceleration at t equals 1/4? Explain the meaning of your answer in terms of the particle's velocity, and then how would the units be explained? So acceleration at 1/4 is very simple. We've already previously in the problem given the equation for acceleration, so we can just fill that in directly. So we have 3/2 minus 9, that's 3/2 minus 18/2, so that's negative 15/2. And then we want to explain how would the meaning of the answer in terms of velocity. So in terms of velocity, the acceleration being negative means that the particle's velocity is decreasing because acceleration at 1/4 equals negative 15/2 less than 0. Okay, so that's what tells me it's decreasing at t equals 1/4. And then they want to know how would the units be explained in context of the particle. So your units here are going to be, you have your, so when you find your, when you found your change in acceleration, your acceleration is change in velocity over time, right? That's how we find that. So that means it's going to be distance over time, because that's velocity. Velocity is the change in distance over time, and then we took that change in velocity further over time. So that's going to give me the way I get my units, okay? So that means my units, in this case, it would be negative 15/2, whatever the distance units are, over whatever the time units are, squared. So that's how we get our units there, okay? Because acceleration is the change in velocity over time. All right, so now let's look at this question. So this question gives us a table and then asks us a bunch of questions about it. And this is a very, very common question for the AP test, to have a table for one of your free response questions. And these are some of the things that are given on the, when we do the table, these are some of the questions that they ask you often. So different things can be asked. This is what happens a lot. So we're going to have a table here that is time and velocity. And it's in feet per second. Always a good idea to sort of underline those things so you don't forget. And the other really important thing is the fact that the velocity is a twice differentiable function of time. What that means, what that tells me is, remember, if something's differentiable, it also means it's continuous. And remember, there's a bunch of our theorems that start off saying, if it's continuous, then all these things are true. Okay, so that could be important there. So we need to remember that. And of course, the table also shows our units here on the left. So again, units, pay attention. Don't want to lose a point because you forgot to put units down. That's silly. We don't want to do that. Okay, A says at time, that's going to make my writing look big, but I guess I didn't write anything except underlines. At time t equals 0, determine whether the particle is moving right or left. So again, how do I know if a particle is moving right or left? It's the velocity. The sign of the velocity is what tells me that. So this exact table gives me the values of velocity. So this is really easy. They already named velocity v. Remember, you can't just randomly start using letters, but they told me it's called v. So I know at time 0, v of 0 equals -4. It's right here in the table. -4 is less than 0. So then I would say at time t equals 0, the particle is moving left. At a rate of 4 feet per second. And make sure you have your units, okay? And again, velocity was given in feet per second. So really simple question because I don't have to find the derivative. They already gave me the answers for that, okay? Question B, is there any time or times during the interval 0 to 15 when the particle is at rest? Okay, so let's go back and look at this table again. So when would we know that the particle is at rest? So we've got to think through the question to figure out what I want to do. Well, I would know the particle's at rest if the velocity is 0. Well, they told me that this function is twice differentiable, which means it's continuous. Well, if the function is continuous, and I look right here, the velocity is -1 and then +1, which means somewhere between 2 and 3, it must equal 0. Now, it could equal 0 other places also, but for sure, by the intermediate value theorem, I know that somewhere between -1 and 1, because the function's continuous, I'm guaranteed that a y value or a velocity value of 0 must exist for some value of t. So that's how I would think through the question first. Okay, so you think through it. What does that tell me? How do I know if a particle's at rest? Well, velocity is 0. Well, look at this graph. Well, hey, it changes from -1 to +1, so got to be 0 somewhere in the middle. That's the intermediate value theorem. Now I'm going to go over and actually answer all that. So now I've kind of thought through, okay, here's all the things that I know. So first of all, before I can use that theorem, I need to say that it's continuous. Well, I'm going to say that v of t is differentiable on 0 to 15, thus it is continuous. Okay, so that's very important. I have to say that it's continuous before I try to use this theorem. And then all I have to do, luckily I have a table, right? So we know that v of 2 is -1 and v of 3 is +1. So we have v of 2 equals -1, which is less than 0, and v of 3 equals +1, which is greater than 0. Therefore, by the intermediate value theorem, there exists a time where it's between 2 and 3. So there exists a time t between 2 and 3 such that v of t equals 0. Thus, the particle would be at rest. Okay, so again, we practice the intermediate value theorem a lot. It's actually normally a pretty easy question to answer on the test. So whenever possible, we would like to get it correct. So important things, we had to say it was continuous. They didn't explicitly say it was continuous, but they told us it's differentiable. We had to show that velocity was less than 0 and greater than 0, meaning 0 is in between it. State that by that theorem, then, there must be some value t between 2 and 3 such that the velocity is 0, thus the particle would be at rest. Okay? And so, again, not that hard to explain, and then they already kind of gave you a lot of stuff there, so you didn't even have to solve very many things. Okay, next part of this question says use the data from the table to approximate v prime of 8. This is also a super common question. And then we're going to explain the meaning and show the computations. Well, we've talked about this many times. So we want to do v prime of 8. So we can't do the exact derivative because we don't have a formula. We just have a bunch of numbers, certain values. So the best estimate for the instantaneous rate of change would be the average rate of change at the points that are the closest we can get. So 8 is in there. So we're going to go between 7 and 10 to get our answer. And so we're going to show that by finding out that approximation. So we're going to say v prime of 8, again, is approximately, and we're going to do v of 10 minus v of 7 over 10 minus 7. And remember, that's perfectly enough to show all of the work, and at this point you can either just write the answer down or you can do 5 minus 3 over 10 minus 7, but we get 2/3. And then be sure you have your units, which is feet per second squared. And it's seconds squared because velocity is in feet per second. So our numerator is feet per second divided by the change in seconds. And then you show the computations and you have your units, but then also it says explain. So remember, here's a perfect time where you would underline explain, show, indicate. So I would go back and make sure I didn't miss anything or find an approximation, right? So all of those things have to be there. I have to find the approximation, I have to show the computations, indicate my units, did all that. What's left to do is explain the meaning, okay? So what this would tell me is at t equals 8 seconds, the particle's velocity is increasing because it's positive at about 2 feet per 3 seconds squared. Actually, I probably would just write 2/3 feet per second squared. Okay, so that's what it means. Let's look at E. E says, or D. D says find the average acceleration for the particle from 10 to 12. So we have to be careful here when we do this and remember how to find it, and we have to kind of write it out because we don't have an abbreviation really for that. So make sure you just say average acceleration. So the average acceleration, remember that would be the change in velocity over time. So that would be v12 minus V10 over 12 minus 10. And we have to do the average velocity over time to get average acceleration or change in velocity over time. And again, you could write the numbers down, 3 minus 5 over 12 minus 10, or you can just do the arithmetic because I've shown the work right here, right? That's all there. So it's -1 feet per second squared. So again, pay attention. We found the average acceleration. That's done. Find, did it. Explain what this means in terms of the velocity. So this means that the velocity was decreasing on average. That's the difference here, right? Decreasing on average, because this is average, at a rate of decreasing, so remember, don't put negative, at 1 foot per second squared. Okay, so make sure you say decreasing at 1 foot, don't accidentally say decreasing at negative. Okay, and then we're going to do E, and then we're going to look at part of the calculator question so that we can talk about how to do that calculator stuff, and then we'll do the rest of all of this in class. So this was kind of a lot of examples, and we'll go over it in class to review. So let acceleration A of t equal V prime of t. Is there a time that t equals c, is there a time t equals c guaranteed such that A of c is 0? Okay, so luckily they told us that we're going to use acceleration A of t equal V prime. So again, what are they saying? Well, is there a time guaranteed such that A of c is 0? Well, they're saying, is there a time that you would have the rate of change of velocity equals 0? Well, if we look and we kind of look at answers that we've already found, for example, we found that the velocity, the average velocity from 10 to 7 or 7 to 10 was 2/3, and we just found that from 10 to 12 was -1. So therefore, somewhere in there, there must be a point where we can get 0, because we're getting a positive number and a negative number, okay? So again, we have to say, because V of t is differentiable, because that was given in the beginning, on that interval, then acceleration is continuous. Okay, so that's important again. Differentiable implies it's continuous. And I have to have continuous for this to be true. And so we found that acceleration, basically the estimated acceleration at 8 was 2/3, which is greater than 0. And then we also found that if you went from 10 to 12, we got -1, which is less than 0. Thus, A of t equals 0 on the interval 7 to 12 seconds. Somewhere in there it must be 0, because we have a positive number and a negative number. Okay, so we're going to skip to example 4, and we'll do this example with the picture, kind of do that one in class. We're going to skip to example 4, where we need to do calculator stuff. So I just want to do this one question right here to remind us about what we need to do for the calculator. Okay, so I'm going to get a new page here that's going to be just a calculator page for the moment. And then let me move this so we just have the handheld, and I'll put this to the side. So I'm going to read the question and give it a moment to think about it. It says an object moves on the x-axis, velocity is this thing. For t equals 4, is it speeding up or slowing down? So before I do anything, don't just grab your calculator and start punching stuff. Let's think about that question. So how do I know if an object is speeding up or slowing down? Well, the way I know is if the velocity and acceleration have the same signs or different signs. So that right there tells me I'm going to deal with this velocity equation and I'm going to be dealing with its derivative. So that means that I need to store this function. I'm definitely going to do more than one thing with it, so I'm going to store it. Okay, so we're going to type it in. So we're going to do the ln, and then remember, just always use x, way safer, because then if you need to graph it or anything, you're good. So ln of x minus 0.15 x cubed, and then plus, and do your parentheses, make sure you enter everything correctly, and get all of your equation entered. And then when you do your exponent, I would use the fraction key just because we need to get used to that, always doing that with fractions. Then get out of that exponent, okay, make sure you're out of it, and then we want to store this. So that was control of var, and I'm going to store it, and I'm going to go ahead and just call it v, but I'm going to call it v of x. Because remember, I used x, and I'm going to hit enter. Okay, so it says it's stored, and it's all good. So now for t equals 4, is the object speeding up or slowing down? Well, that means I need to find out what is v of 4 and what is a of 4, because I need to know, are they the same signs or are they different? So velocity at 4 is going to be, for me, just to put v, because that's what I called it, of 4, and then hit enter. And I get my answer. So v of 4 is 4.497. Acceleration at 4 would be the derivative. So I'm even going to write that. That would be the derivative evaluated at 4. But remember, to do it in the calculator, I can let the calculator do that. There's a couple of ways. I'm going to do it different than the last time we did it. So shift minus gets me the little derivative template. Remember, I'm always going to use x, and then I can just say of v of x. But then I want to evaluate it specifically. I don't want to ever write down on a calculator question what the derivative was. I just want the answer. So remember to do evaluated at, it's control of the equal sign, and I pick my vertical bar, and then I'm going to say x equals 4, because I'm going to evaluate the derivative of the velocity at 4, and I hit enter. And then boom, here's my answer. So I get negative 2.713. Then I need to answer my question, speeding up or slowing down. So I would say, since v of 4, and I'm going to just write right here, greater than 0. And then I'm going to put a less than 0 right here. And so I'm going to say v of 4 and a of 4 have opposite signs, because I already compared them right up there, so I don't need to do it again. I said that one is greater than 0, one is less than 0. Then the object is slowing down. At t equals 4. Okay, so that's all we have to do. So just remember, that's what's really nice about the calculator questions, is you can let it do all of that nice stuff for you instead of you trying to do all of that work and do those derivatives and everything. Let it do the work and just show that you did it, that you did v of 4 and you did a of 4 and so on. Okay, then the next question is, when does the particle change directions? So to determine if it changes directions, I need to know, when is the velocity 0? Now, I could use the solver for that, but you know what? It would be better for me to look at this on a graph, because to know if the particle changes direction, I need to see if the velocity changes signs. Well, a graph would be a way easier way to figure that out. So I'm actually going to add a page here, and I'm going to add a graph. Now remember, I already called this v of x, so I'm just going to write v of x and then graphic. Now I only care about 0 to 6, so I'm going to just trace, because I'm going to go find those zeros. So I'm going to do menu trace, graph trace, and I'm just going to start working on the graph, and I'm going to trace, and it says 0 right there. If I hit enter, it will stick that 0 there. Okay, so that helps, so I know that number, and then I'm going to go over here and notice that I get another 0, and it is less than 6. So I can hit enter, and then clearly later it's going to be, it's not going to be something that I can, it's going to be greater than 6. So basically I have my two places that I have zeros, and I can clearly see, so at t equals 0.391 seconds, v of t changes from negative to positive, so the particle changes direction. And then we also have at t equals 5.01, and here's the bad part about that, is it doesn't show me the whole number. So what I can do, and we'll talk more about this later, but there's a way for me to select this. It's going to be kind of hard for me to do this on this emulator, I think. Let me see if I can move it. So you want to move it out of the way. For me, it was on top of that. But you're going to get right here on this text, and you're basically going to kind of double click. So you've selected it, and then you're going to store it. Oh, and it erased it. So let me undo. That's the hard part. It's really hard to do on this emulator. You actually will probably have a little bit easier way to do it. But you click and then store, and I'm going to call it like A. And we'll practice this in class, but then if I do that, what that does is mean I can go back to this calculator page and just type A and hit enter, and I get more decimals. And so we'll practice that several times, because remember, we have to have 3 decimal places. So remember, it truncated or rounded, doesn't matter. So 5.007. Again, velocity changes from this time positive to negative, so particle changes direction. Okay, so that's all I have to do. So that's a little bit of practice with your calculator. If you are struggling sometimes with your calculator, then remember, practice that more. Rewind it, make sure that you can store things, that you can solve things, that you know how to graph, find zeros, etc., etc. So we will do the rest of the examples that we're going to work in class.